How plastic is made. Plastic has become so deeply woven into our lives that imagining a world without it feels impossible. From food wrappers to airplane seats and even the keyboard you're typing on, it's everywhere. Global production has crossed 380 million tons a year, and it keeps doubling roughly every decade. But how does something that begins deep underground as crude oil end up as a shiny Coke bottle, or get reborn as one through recycling? Let's find out. Here's a weird fact before we begin. There's actually a term for the tiny plastic pellets that become everything from toothbrushes to car parts. They're called nurdles, and trillions of them are produced every year. So many, in fact, that scientists estimate they're now the second largest source of microplastic pollution in the ocean. It's a strange thought, isn't it? The same little beads that make your shampoo bottle are quietly littering beaches worldwide. If you like diving into strange factory secrets like this one, hit subscribe and maybe drop a comment with the product you've always wondered how it's made. We might just feature your name in the next video. Part 1. From oil to building blocks. We'll start at the beginning. Deep in oil fields, rigs drill into the Earth's crust thousands of feet below the surface. This is where crude oil lives, thick, black, and full of hydrocarbons. Pumps and pressure extract it from the ground, and that oil travels to massive refineries. There, it's heated to about 400 degrees Celsius inside towering distillation columns. Think of these as sorting skyscrapers from molecules. The lighter gases like ethane and propane rise to the top, while heavier fuels like diesel and asphalt sink to the bottom. Ethane and propane are special. They're the building blocks of plastic. Once separated, they're sent to a cracking plant. Cracking sounds dramatic, and it kind of is. The process literally breaks apart large hydrocarbon molecules into smaller, more useful ones. In this case, ethane and propane are transformed into ethylene and propylene, the two monomers that form the backbone of most plastics. Part 2. Polymerization. Now comes the magic part, polymerization. This is where chemistry meets creation. The ethylene and propylene molecules join together in long repeating chains, forming polymers. There are actually different types of polymerization. In one of them, called addition polymerization, a catalyst breaks open the double bonds in these molecules, allowing them to snap together one by one into a solid chain. That's how polyethylene, polypropylene, and PVC come to life. If you've ever touched a grocery bag or handled a plastic bucket, you've held the results of that chain reaction. Some plastics like nylon and polyester are made a bit differently through what's known as condensation polymerization, where two different molecules join and release water as a byproduct. After polymerization, the material looks like a soft molten mass. It's extruded into long strands, cooled and chopped into tiny uniform pellets, those nurdles we mentioned earlier. They're dried, packed, and shipped off to manufacturers who melt them down again to shape into products. Part 3. Molding the products. At this stage, the pellets can be molded into virtually anything using techniques like injection molding, extrusion, or blow molding. Injection molding pushes molten plastic into molds for things like phone cases and car interiors. Extrusion creates pipes and plastic films. Blow molding gives us hollow bottles and containers. Here's a quick question. Would you rather work in a molding factory surrounded by the constant hum of machinery, or never set foot in one? Drop your answer in the comments. I'm curious who'd take the noise for a behind-the-scenes look. Once molded, the plastic is cooled and solidified, often using water channels or air jets. Additives like colorants, stabilizers, and UV protectants are mixed in during production to give the plastic its desired look and resilience. That's how we get blue detergent bottles, flexible food packaging, or glossy white electronics. Part 4. Recycling. But the story doesn't stop there. Every plastic product you've ever touched will someday reach the end of its life. The real question is, what happens next? Let's jump to southern Germany, where heaps of discarded packaging arrive in bright yellow bags and bins. Every year, over 2.5 million tons of plastic packaging waste pile up here. From bottles to yogurt cups to random bits of film, it all ends up in sorting plants like the one in southern Hessen. Imagine a conveyor belt stretching 2.5 kilometers long, carrying an endless stream of plastic chaos. At the first stage, a massive rotary sieve sorts materials by size. Smaller pieces fall through, larger ones continue onward. Air separators blow lighter films away from heavier plastics. The goal is to isolate specific types like PET, HDPE, and polypropylene, the three most valuable recyclable plastics. This is where technology gets impressive. Infrared scanners identify the type of plastic based on how it reflects light, and precise bursts of air shoot out the right pieces. PP bottle caps, PET bottles, and HDPE containers each get separated into their own streams. Even with all that automation, workers still sort by hand to catch anything the machines miss. Most people think every bit of this process is done by machine, but human workers still play a big role in quality control, removing anything that doesn't belong. Did that surprise you? The result is neat, tightly packed bales of sorted plastic with up to 98% purity. These bales are valuable. They're sent to specialized recycling facilities like Systech Plastics in Thuringia, where the next transformation happens. Part 5. From waste to recycled pellets. Here, HDPE bottles are fed into a shredder and ground into small flakes. They're washed to remove any leftover residue from shampoo, yogurt, or detergent. The flakes are then dried and color sorted. This part is fascinating. Lasers and air jets work together to separate flakes by color at lightning speed. Tens of thousands of flakes per minute fly across a chute, illuminated by LEDs. A computer detects even the slightest color differences and shoots compressed air to separate them. Drop your guess in the comments. How pure do you think these color-sorted flakes get? 90%? 95%? The actual number is over 99%. That's cleaner than many newly produced plastics. These sorted flakes are melted at about 220 degrees Celsius, filtered to remove impurities, and cooled into new granules. They're basically recycled nurdles, ready to start life again as something new. At the Vanna and Metz factory in Mainz, these granules are turned into detergent bottles, all made from recycled plastic. Inside a blow molding machine, the recycled HDPE is heated, softened, and inflated into bottle shapes. Excess plastic is trimmed away, and within minutes, the bottles are ready to be filled. Around 5.5 million of them are made each year, all from material that once sat in someone's yellow recycling bag. It doesn't stop there. The caps on those bottles, made from polypropylene, also come from recycled material. The plant even reuses PET from old beverage bottles. Right now, each PET bottle made here contains around 20% plastic from the yellow bag system. But the company plans to increase that number year by year. This is what the industry calls closing the loop. A bottle becomes another bottle. A cap becomes another cap. It's not perfect yet. A lot of plastic still ends up being burned for energy, but it's progress. Every reused piece saves raw materials and reduces dependence on oil. Part 6. The future of plastic. If you think about it, it's almost poetic. The same plastic that once held your shampoo could return to the shelf reincarnated as a detergent bottle. Would you trust using a bottle made entirely from recycled plastic? Or do you think the industry still has a way to go before it feels the same as new? Let me know in the comments. Even with today's technology, we haven't built a truly endless recycling loop. Each recycling cycle slightly weakens the material structure, meaning it can only be reused so many times before it has to be discarded or downcycled into something less demanding, like park benches or fleece fabrics. But every loop counts, and every improvement brings us closer to the goal of a circular plastic economy. At the end of the day, plastic is both a marvel and a problem. It's light, durable, and cheap, which is exactly why it's so hard to get rid of. It revolutionized the world, from food safety to medicine. But now, it's forcing us to rethink everything about waste. We've seen how crude oil turns into shiny pellets, and how garbage turns back into raw material. But what about bioplastics? The ones made from plants instead of oil. Could they be the next evolution in the plastic story? Drop a comment with what you think. Should we go behind the scenes of plant-based plastic next? Or maybe see how biodegradable cutlery is made? The best suggestion might get a shout out in our next video.